Human perception versus machine vision. Limited versus entire EM spectrum, electromagnetic spectrum. The electromagnetic spectrum wavelength in meters 10 power 3, 10 power minus 2, 10 power minus 5, 10 power minus 6, 10 power minus 8, 10 power minus 10, 10 power minus 12. Radio, microwave, infrared, visible, ultraviolet, X-ray, gamma ray. Radio in 10 power 3. Radio signal. Microwave 10 power minus 2. Infrared 10 power minus 5. Visible 10 power minus 6. Ultraviolet 10 power minus 8. X-ray 10 power minus 10. Gamma ray 10 power minus 12. Here the frequency 10 power 4 in hertz. This is meters, 10 power 3 meters. Here this is 10 power 2 meters, this is 10 power minus 5 meters, this is 10 power minus 6 meters, this is 10 power minus 8 meters, this is 10 power minus 10 meters, this is 10 power minus 12 meters in gamma ray. Frequency in hertz, here 10 power 4 hertz, here 10 power 8 hertz. Microwave or microwave in 10 power minus 2 meter, frequency is 10 power 8 hertz. Here radio signal, that wavelength is 10 power 3 meters, frequency is 10 power minus 4, 10 power 4 hertz. Infrared wavelength meter is 10 power minus 5 meter. Corresponding frequency is, for that frequency is 10 power 12 hertz. Visible wavelength is 10 power minus 6. Here in between 10 power 12 to 10 power 15 is the visible frequency, 10 power 12 to 10 power 15. Ultraviolet actually here before 10 power 4 hertz frequency radio, before 10 power 8 microwave, before 10 power 12 hertz infrared. So in between this 10 power 12 to 10 power 15 hertz, 10 power 12 12 hertz to 10 power 15 hertz visible, up to here visible only. Ultraviolet wavelength 10 power minus 8 having frequency 10 power 15 to 10 power 16 hertz. In X-ray wavelength having wavelength 10 power minus 10 meters, in between 10 power 16 to 10 power 18. Gamma ray wavelength 10 power minus 12 to 12 meters, frequency up to 10 power 20 hertz. This one here, this range only we can visible. This range only visible between here. Okay. From 10 power 12 to 10 power 15, 10 power 12, 13, 14, 10 power 12, 10 power 13, 10 power 14, 10 power 15, up to we can here. 10 power 12, 10 power 13, 10 power 14, 10 power 15. It's you can see. Here image processing, image analysis. Image processing means image analysis. Low level, mid level, high level. Low level image acquisition, image enhancement, image compression. Mid level image segmentation, image object recognition. High level scenes understanding, semantics. Up to here, this is the image processing, that is image acquisition, image enhancement, image compression, image segmentation, image recognition, up to image processing. Image analysis, that is computer vision, pattern recognition, etc. Image segmentation, object recognition, scene understanding, semantics. These all are under image analysis, computer vision, pattern recognition, etc. Image acquisition and representation. Here, an example of the digital image acquisition process, energy illumination source and element of a scene. Imaging system C, figure C, figure D, projection of the scene onto the image plane. E, digitized image. Here, illumination energy source, scene element, imaging system, internal image plane, output digitized image. A is the this one A, energy source, okay, energy, and then B is the, that is energy illumination source. B, an element of the scene. B, element of the scene, and then C, element of the scene. C, imaging system, imaging system. C, D, projection of the scene onto the image plane. This one, projection of the scene onto the image plane. Digitized image, output digitized image. Examples: brain MRI, cardiac CT, fetus ultrasound, satellite image, IR image. All are available in Wikipedia, Radiology, RSNA, emapint.com, www.imaging1.com. Image acquisition, image acquisition, camera scanner, digital camera, get images into computer, camera plus scanner, okay, camera plus scanner, digital camera, get images into computer. Image representation, discrete representation of images. We will have carve up image into rectangular grid of pixels p of xy. Each pixel p will store an intensity value in 0 1, 0 black, 1 white, in between gray. Image size m cross n, mn pixels. Here this top, this black here, gray. Gray what he told, in between 0 and 1. 0 means black, 1 means white. So here 1, here 0. Gray, this one, no 0, no 1. Color image, red, green, blue, RGB, 1 0 0, 0 1 0, 0 0 1. This blue, this green, 0 1 0, this one red. So colors along red axis 0 1. Here in this red axis, here 0, it will increasing here approximately 0.5, here 0.25 of red, here 0.75, here 1. This is the pure red. Here 0.6 red, green 0, red means 0.6 means approximately here, okay. Green 0, 0 means approximately here, okay. 0.8, 0.8 means here approximately in blue, okay. Then output here 0, here nothing. So here this color we got. RGB channels, red, green, blue, only red, only green, only blue, RGB, okay. We can say 4 2 1. Video frame by frame, 30 frames per second, 30 frames per second. This is the 0 video frame by frame. So 0th frame, first frame, second frame, third frame, fourth frame, fifth frame in per second approximately. Sixth frame, seventh frame, eighth frame, ninth frame, 10th frame, 11th frame, 12th frame, 13th frame, 14th frame. Image enhancement, image enhancement. This one image enhancement. This image here enhancement. Okay. Image restoration. This image restored here. This image enhancement here. Okay. Image compression. Image compression 100% fidelity. Image is 725 kb. 90% 250 kb. Here 10% 37 kb. 1% 20 kb. This is the image compression. 100% fidelity. That time this image is having 725 kb. And then here 90% 250 kb. 10% means 37 kb. 1% means 20 kb. Video compression, image processing, image analysis, low level, middle level, high level. Okay. Here image acquisition, image enhancement, image compression in this low level. Middle level image segmentation, object recognition. In high level scene understanding, semantics. In image processing, image acquisition, image enhancement, image compression, image segmentation, recognition up to. This is the image processing here. Image analysis, image segmentation, object recognition, scene understanding, semantics. These are